Anyone need anything before we start? You need a calculator and your notes, pencil maybe? And then we're going to start from the bottom and work our way up because the top example is by far the most challenging. Can you need it?
Yeah.
Sure. Anyone else need it? All okay? Okay, so now that you guys are little trig wizards and witches, we're going to make things a little bit more difficult. And you're going to have two angles of elevation or depression. So really it's kind of like two problems within one, okay? That's kind of what I want you to think about while we do these problems. So here we go. It says Vernon is on the top of a deck of a cruise ship and observes two dolphins following each other directly from the ship in a straight line. Vernon's position is 154 meters above sea level, and the angles of depression to the two dolphins are 35 degrees and 36 degrees. Find the distance between the two dolphins. What should you probably do first? That's not triangle. I'm not going to be as detailed with these pictures just because we clearly know I can't draw and it almost makes it more confusing. So I might just use letters this time. But here's Vernon, right? He's looking up off the cruise ship. He's looking down at the dolphins in the water. Okay, now let's go back and read and we can kind of label some more things. Let's see here. It says Vernon's position is 154 meters above sea level. Where's 154 going to go? Yeah, the vertical, right? So let's put 154 here. And it says the two angles of depression are 35 degrees and 36. So remember, those are outside your triangle, right? So he's looking down and right here is 35. So where would that be in your triangle? Right here, right? The bottom. So that's to our first dolphin. So I'm going to do D1 for dolphin 1. Then he looks down a little bit further at an angle of 36 degrees. So now where is that going to be in our triangle? Right here, right? This would be alternate interior to this guy. So that's to the second dolphin. And now our goal is we want to figure out how far away these two are. That's our goal. That distance right there. Does anyone have like a plan? What we can maybe do? Yeah.
Solve the bottom on both triangles and just subtract.
Right. Right, here's a right triangle, solve for this distance. And here's a bigger right triangle, solve for that distance, and then subtract them.
That's a lot of work.
It's really two problems in one, right? But you're right, a little more work than the other ones. Okay, let's solve for this distance right here. Okay, so what's 154 with respect to 36? Opposite, and x would be adjacent. So we'll use tangent. You guys are all good. I didn't need to walk through it like that. So tangent of 36, 154 over x.
How are you rounding up to nearest whole number?
We might well, because this is ground to nearest meter, right? So we're going to have x equals 154 divided by tangent. You guys let me know what you get.
212.
I think that sounds familiar. I think that's, are you guys okay with 212?
Yeah.
Okay. Okay, so that was for x. Now let's find this bigger bottom one. I'm going to call it y. Now you're looking at the big triangle, right? Can we agree it's still tangent? This time it's going to be tangent of 35 equals 154 over y.
Should be like 8 meters apart.
I think that sounds what we should get. I don't remember though off the top of my head. So what did you guys get for y here? 220. And then what do we do to 212 and 220? Subtract. So what should we get?
8.
8. So 8 meters. So that really wasn't that bad. It really wasn't that bad. How about you guys read the next problem and see if you can draw your own picture? To be honest, it's very similar to this one, but just a different scenario. It's gonna be like a double triangle situation. And I'll catch up to you.
The exact.
Yeah, unfortunately, the angles are the same, but hopefully that just teaches you. Math is just a pattern. Learn the pattern, and then you can solve problems. So that's all math is.
No.
It won't be the same answer because the building's not 154 feet. But it'll be very similar. I'll let you guys get a head start. I'll catch up. What did you guys get for an answer? You guys actually did a problem like this on that main worksheet, I think, where the people are driving towards the Joe Burrow statue, I think, or something similar to this, without knowing that's what you were doing. Okay, this top one, a little more complicated, and just keep your work neat. So whatever I kind of write on the board, I recommend you write on your notes, and just try to write small, because there's kind of, you'll see why. Just keep your work neat and try to write small so it all fits. That's all I'm going to say, okay? Okay, so this one says to estimate the height of a tree she wants removed, Mrs. Long sites the tree's top at 70 degrees angle of elevation. She then steps back 10 meters and sites the top at 26 degrees. If Mrs. Long's line of sight is 1.7 meters above the ground, how tall is the tree to the nearest meter? So we're looking for how tall the tree is, but we run into a problem. Does anyone know what our problem is here? Yeah. Fun.
Full number. Like a full side.
Yeah. So what Landon notices, we don't have like a full side here. So I think he's saying that we have two different variables that we'll need in one equation. Now, can you guys think back to Algebra 1 or Algebra? What did you do when you had an equation with two different variables?
Substitute.
We have to substitute, right? In a systems of equations. You guys kind of remember doing stuff like that? It'll be okay. We just gotta be organized with our work, all right? So let's not even worry about what we have to do. Let's just look at triangle ABC, okay? You guys see that smaller one, triangle ABC? So if I mark angle 70, what side is X?
Opposite.
Opposite. And what side is Y?
Adjacent.
Adjacent. So what trig function would we use?
Tangent.
Tangent. Okay, so we're gonna write that right here. So tangent of 70 equals X over Y. So that's one of our equations. Now we're gonna go to the big triangle, triangle ADB. Same kind of situation, right? Angle 26 is our reference angle. What side is X? Opposite. Now here's kind of a unique thing. How do I label this? Like what would that length be?
And plus what?
Good. And what side would that be?
Adjacent.
Adjacent. So what trig function are we using there?
Tangent.
All right, so then our other equation is going to be tangent of 26 equals X over 10 plus Y. So those are our two equations, and do you guys see how they both have an X and a Y?
Yeah.
And I think it was Samuel said we have to do some substitution, but before we can substitute, what do we have to do to our equations?
Simplify.
Kind of like simplifying. Because before we can substitute, what do we have to do? Because we replace a variable for something else, you have to figure out that it's equal to something.
Yeah.
Right? So what variable should we probably get alone in both of our equations? I'd probably think X, right? Because X is all by itself anyways in the numerator. So if we were to get X alone here, what would we do? Yeah, multiply by that Y. So we'll have Y times the tangent of 70 is equal to X. Now what's kind of goofy is this denominator has to stay together, so we're going to put that in parentheses and then multiply it over. So then this one over here is going to be 10 plus Y in parentheses times the tangent of 26 equals X. So now do you guys see how we have both of our equations equal to X? Since they're both equal to X, we can set this equal to this, because they're both equal to the same thing. Even though they look kind of weird, they're still equal to the exact same thing. So now I'm going to write Y tangent of 70 is equal to parentheses 10 plus Y tangent of 26. Now you've done this before, not with trig, but remember if you were to type in tangent of 26 in your calculator, it's just a decimal. Your calculator knows what this is. This is just a number. So if I have a number in front of a parentheses, what do you typically do to get rid of that number in front? Distribute, right? So we just got to distribute that in there. So remember, this is just a number. Don't think it's anything more. It's just a number. So our left side is going to stay the same. Now we're going to distribute, so we'll have 10 tangent 26 plus Y tangent 26. And you're just solving the equation for Y. So if you just think of like you're solving equation skills, what would make the most sense to come now? We can't get rid of tangent yet. We're trying to find Y, but if you have Y on both sides of your... Yeah, we want to get our Y's to the same side, right? I'm probably going to bring this guy over there. So if I'm adding Y tangent 26, we're going to subtract it over.
So then would you do 70 minus 26?
No, we can't do that. You're getting close. I'll show you. We got one thing you got to do before then. Before that, excuse me. So we got our y's to the same side. But how am I going to get y just to equal y when it's in both of those?
I should do tangent 70 and find out what the number is.
We could. I want to wait to do that, though, otherwise we're going to get really approximated answers. Do you guys know what the opposite of distributing is? Factoring. You guys see how we can pull a y out of both of those? If I pull out a y, I'm just left with tangent 70 minus tangent 26. So we're just manipulating it to help us solve our problem. We still have the same number here, it just looks different. If I were to distribute that y through, I would end up where we started. So this is still the same thing, we just made it look different to help us solve our problem. Now what's our last step? I want to get y alone. What's the opposite of multiply? We're going to divide by this whole thing. So this is our numerator, and this now becomes our denominator. So y equals 10 tangent 26 all over tangent of 70 minus tangent of 26. When you type this in your calculator, you need to be careful of parentheses. Like if it's open, you gotta close it. You gotta put your whole denominator in a parentheses together. If you guys want, let's just see what we can get on our own, okay? Your final answer for y should be 2.16. Okay, let's just see if we can try it on our own.
I'm pretty sure x is 5.
It's close. You should get 2.16. Not yet. That's not our final answer. That's why you don't want to type. You don't want to cut corners because this is going to be an approximation, which is an approximation for the next one, and so on. If you're not getting 2.16, wave me over and I can help you. See what you did. Okay, you see how you have the open parentheses there? You gotta close that first. Okay, so we're gonna get second insert, close that, and now you can try that. Okay, let's see what else. Oh, so you got that open parentheses, we gotta insert another one. And it equals. All right, here we go. So we just gotta close our parentheses. You guys get it? Does everyone have a calculator like this?
What is supposed to be?
Let's type it in together. Do you have a calculator like this one or from the board? 2.16. You're gonna do 10 tangent 26. Now do you see how there's an open parentheses in your calculator? You gotta close it right now. Divided by, now this whole thing in the bottom has to be in parentheses, so parentheses, tangent 70, gotta close that parentheses of your 70, minus tangent 26, close the parentheses, and then another one. 2.15. You just gotta look at your
What are we supposed to do?
2.1583.
Yours will be probably, I don't know how you're supposed to do it, I know just do yours all in parts, but let's figure out what that is. Just figure out what the top is.
Did you do?
Now just go like 3 decimal places, so we're at just like 4.877 on the top, that's your numerator. All over. Now we'll type this one in and we'll get that as a decimal. If you like this part of decimal, that part, whatever.
And,
2.56. Yeah. 2.26, yeah. And I'm just like, oh, we're close enough. Oh, now we have to do the denominator, so let's do second insert. That's okay, we'll just write the number by, which is now we just have to parentheses. Tangents have to be.
Running 78.
Nope, it starts with grade.
Well, don't you buy some
Down.
1.7?
Okay, and then minus.
Is there that's mine?
Okay, that was a doozy. But the sad thing is, you guys were not done. I know. That's only y. So y should equal 2 point. What do we say? 1.6. 1.6. Ick, right? But what was the end goal? How tall the tree is, and what variable is that? X. So what I would do, this first one we wrote is the simplest. So let's plug in y here and solve for x. So we're going to have tangent 70 equals x over 2.16. Multiply it over.
5.9.
Is that what it is?
Yes.
6.
Well, we're not going to round yet. 5.9 should be your x. But now that's still not your final answer. Why?
You subtract it.
Plus 1.7. Or minus 1.7. Add 1.7.
We got to add, right? Because her eyes are off the ground, so we're not accounting for that 1.7 up to her eyes. So we got to add 1.7 to this. I'm making you mad. I'm sorry.
No, not you.
Yeah, it's funny. I'm never gonna be able to do this.
I know. Right, this is hard, but you guys should feel good. Like, not very many people can do this. Like, you should feel like really good about yourself that you can like rationalize through. Like, this is
Yeah,
incredible.
but
Like truly, like pat yourself. I don't want to be silly, but like truly, this is
if it's
awesome.
a 7-foot tree, you can pretty much estimate.
Yeah, I know. Is the context of the problem great? No, it's terrible. But the fact that you can do this math, like, you guys are good. Like, it's incredible.
Completely make fun of me.
You can make fun of it.
No, they would, if I showed them